Hello and welcome back to this session. In the earlier session, we had seen the basic C programming constructs like the identifiers, the constants and the variables. In this session, we will continue with the rest of the programming constructs. So we will start with the declarations part. Earlier while we are talking about the structure of the C programming, we had started with the preprocessor directives and then comes the main and then comes the declaration part. What is this declaration part? After the preprocessor directives also there is a declaration part called as the global data declaration, and in the main programming also there is the declaration part. What we have to declare here? So a declaration associates a group of variables with a specific data type. So here we are assigning some sort of job to each and every variable, some sort of data type to each and every variable. So whatever the variable that we are selecting, we must assign a data type with the variable. In C, all the variables must be declared before they can appear in executable statements. Like suppose if you take the case of a Visual Basic programming, there is no need of any declarations before the use of the variables in the programmable executable statements. But in case of C, whatever the variable that we are using it in the executable statement, that we must exactly declare at the declaration part. And that particular declaration part, maybe for the data it is the data types, and for the function it should be the return data type for the functions. So the functions we call that as the prototype of the function, and in the data we call it as the data type. So in the global declarations also, suppose if we are using it for the complete program, and in the other programs also we declare it at the global declaration part. And suppose if it is only local to the program, we call it as the local variables, and we use it in the local declaration part. So some of the examples I had mentioned here, like A is the variable name, and here we are assigning the A variable name with a data type called as int. And then we can use the multi declarations also. Suppose if A, B, C are three variables, and then if they want to be like, so suppose if we want to declare them as integers, then we can use the multi declarations like int A, B, C. Like character flag, likewise float also we can declare a variable with the float, a variable with the double also we can declare in the similar way. Then coming to the symbolic constants. So there we had talked about the integer constants, the string constants, the character constants and the string constants. So likewise floating type constants. Likewise we have a constants called as symbolic constants. What is the basic purpose of the symbolic constant is that it is the name that substitutes for a sequence of characters. Like suppose we have a pi value to be inserted as 3.1415. Wherever it appears as pi, we have to substitute the value as 3.1415. So this is a kind of substitution mechanism that we have in C programming language, wherein which we can associate a type of data value to a sequence of characters. Like in order to achieve this particular constant mechanism, symbolic constant mechanism, we have to have a preprocessor to be declared, like preprocessor directive to be declared in the form of like hash define. This is define is the keyword that we have to use, and any name we can put in the string of the characters. Like here I had put RATE with the value 0.23. Wherever in the program there appears RATE, then we can, that particular RATE text string of characters is being replaced with the value 0.23. Likewise PI value will be replaced by 3.1415. Likewise wherever true is there, TRUE in uppercase letters is there the value of 1 is being substituted. So what is the difference between the symbolic constant and a variable? This is nothing but whenever we are declaring a value in the form of a variable with the specification of a data type, then what we are achieving is during the program execution the variable value may be changed. But in the symbolic constant, the value remains the same throughout the program. Wherever the text appears, automatically the value is being replaced. That is the difference between the variable and the symbolic value, or else the symbolic constant and the other constants. Then how many types of statements are available? So in the structure of the program I had mentioned a printf statement. That itself is a statement. And how many types of statements we can use in C? We can use an expression statement, we can use a compound statement, and we can use even a control statement. Expression statement is nothing but we are not assigning anything and we are only placing the expression there, like we place in the mathematics. The same is the case. And suppose if it is a compound statement is nothing but it is a group of statements. And those particular statements, suppose if you are using some looping construct or else branching construct. Suppose if a set of statements, like one or more statements are to be executed by that particular condition, under that particular condition, then we will be placing a kind of set of statements there. And that particular grouping is called as the compound statement. And this compound statement, whenever we want to place in the C programming, it should be starting with the curly brace and it should end with a curly brace. So this is the way we this is the way we represent the compound statement. And then there is a control statement. Control statement is nothing but it is a type of condition. The statement is placed against the condition check. Like a condition is being placed. A condition is placed, and again if it is true, some set of statements are being executed, and if it is a false, the other set of statements are being executed. So in order to delimit each and every statement in C programming language, you have to use a delimiter called as the semicolon. Suppose if you are using a printf statement, then it should be delimited with the semicolon. Suppose if you are using the scanf statement, it should be delimited with the semicolon. Suppose if you are using the preprocessor directives, there is no need of placing any semicolon there at the delimiting stage. Those are preprocessor directives and these are the statements that we are using in the executable program. So what are the different types of operators that are available? Till here we had seen the identifiers, the constants, then the declaration statements, and then the type of statements that are there in the programming language. So there should be some sort of arithmetic operators, logical operators, and as well we have to have the relational operators in order to have the conditional statements also. So what are the set of arithmetic operators that are available in the C programming language? Let us see. So there are a list of plus is there, minus is there, star, forward slash is there, and a percentage symbol is there. For each and every symbol, for each and every operator, a kind of purpose is mentioned against to the operator. One is the plus, that is meant for addition, minus is meant for subtraction, star is meant for multiplication, forward slash is meant for division, and there is another symbol called as percentage, wherein which if you does the division, if you want to the remainder part, in the division part, whenever we use the forward slash, it gives the quotient as the answer, quotient as the output. And if at all if we want to have the remainder as the output, we should use the symbol called as the percentage symbol. So that doesn't display the quotient, but it displays the remainder part. Then we will have the logical operators, the relational operators like greater than, equal to, less than equal to, and we have another in order to equate, in order to check the condition that both the variables like A is equal to B, then we have an equal to symbol with two equals, then not equal to is there, wherein which we are placing here the exclamatory mark, and then we have to use the equal to symbol in order to represent the not equal to in the relational. Then we have the logical operators called as ampersand, which is two ampersands, which is meant for A and D and then or, and we had seen already an exclamatory symbol that we were using for the not equal to, which is meant for the not symbol. So here what is the purpose of using the logical operators? Suppose if you want to have some compound relations like A and B, A is equal to B and C is equal to D is to be checked. And if both of them are true, then only the following statement should be executed. In that particular compound kind of thing, compound relational operation, there we have to use a logical thing also. Like in order to check the first condition true as well as the second condition also true, we are using there the AND symbol. Likewise, if there is A is equal to B or C is equal to D, then there is a set of statements to be executed. Then we are placing there the OR statement. Suppose if not A is to be checked. Likewise, we use the logical operators not also. So in this way we have the logical arithmetic, in order to have the arithmetic calculations we have the arithmetic operators, in order to have the logical calculations we have the logical operators. If we have the relational things that are to be done induced into the programming, we have the relational operators also. So there are like a large set of operators that are available in C programming language, which fulfills the each and every kind of requirements, basically ranging from the arithmetic to logical to relational. Then there is an operator called as the assignment operator. So basic purpose of this assignment operator is nothing but we can assign the value to a variable. That also comes into the assignment operation, and also an expression like sum is equal to a plus b. This is nothing but we are adding a and b values, and we are assigning that particular value, the total value, to the SUM. So the basic syntax for this particular assignment operation is identifier is equal to expression. Here you can take one variable, one value to be assigned to anything, or else even the expression wherein which the values are being fetched from other things also can be placed here. Like the examples I have shown here is a is equal to 3. This is the basic assignment operation. The value is being assigned to a variable, or else x is equal to y. Whatever the y value is there is being assigned to the x. Or else we can place, like I had told you, the expression also can be placed against an identifier, like area is equal to length into breadth. So whatever the length value is there, that is being replaced here, and whatever the breadth value is there, that is being replaced here, and the whole, both of them are being multiplied, and the value, the product is being assigned to the area. So in this way the assignment operator works. Then comes the conditional operator. So this conditional operator is nothing but a kind of ternary operator. Ternary operator, here we are taking the case of one question mark and then a colon. So this particular pair comes under a operator called as the ternary operator. What here the conditional operator does is, here we are writing one expression, and suppose if there is a question mark, suppose if the condition is true, then the value or as the expression 2 is been assigned, otherwise expression 3 is been assigned as the value. So by looking into the example you can clearly understand that I less than 0. If this is true, basing upon the value of the I, if it is true, then 0 value is been assigned to that particular expression, conditional operation, or else 100 value is being assigned to the conditional operation. Or else this conditional operation can also be used like an assignment, like this condition is test, fetching a value, and then that particular value is to be assigned to Z. Like here in this case, in the second example, J is equal to F less than G. If the condition is true, the value of F is being assigned to J. Otherwise, if it is false, the value of G is being assigned to J. So in this way the conditional operator works. So this particular thing can also be achieved by if-else statement. Like if the condition is true, the value of the expression 2 can be assigned. If it is false, the value of the expression 3 can be assigned. In this way we can also use the if-else statements in order to fetch the same kind of requirement in our programming. But this conditional operator is very shortcut operation method in order to use the same if then else statement, wherein which the statements are very minimum. Then there are some control statements. For each and every programming language, whenever we are writing some sort of programs, so the programs may not be executed in the sequential way. Yeah, there may be some sort of thing wherein which if at all the condition or a particular range of values are to be met, values are to be tested, and if at all they are met as true, then a fixed kind of statements like the compound statements are to be executed. In that case, we have to have certain kind of things, controlling mechanisms, wherein which for certain range of values, certain range of variable names values, those particular statements are to be executed. Otherwise, there should be some sort of exit kind of thing. So in order to have certain kind of requirement, we have the control statements. One is we have branching statements, and within the branching statements we have the simple if statement. Simple if statement is nothing but it is a kind of mechanism wherein which if there is a condition placed in between the braces, and then if it is true, the statement or statements can be executed. So if x is less than 0, printf %d comma x. So if x is less than 0, then this should be printed. Otherwise, this if statement should be ignored and it should come out from the branching statement. So this is a kind of branching. Here this is not a kind of statement wherein which we are trying to execute like a condition, like a kind of looping. Here this is a kind of branching statement wherein which we are testing only one condition and basing upon that particular condition and we are executing that person. Suppose if this particular condition is being placed in a conditional statement, like in a conditional, not in a conditional statement but in a looping construct, then it can take a various values for that of the x. And then we have a next construct called as the if else construct, just a kind of modification to this particular if statement. In here this particular if else statement, what we have is, there we had ignored the else part. Here we are connecting the else part also. Like if the statement, if the expression that we are placing here is true, then the statement 1 is executed. Otherwise, if it is false, statement 2 is being executed. So in order to get that particular requirement into the programming, we have to insert a if else statement. Here I had given you one example, status is equal to yes. Here I have to place only single quote, there is a printing mistake. Yes, if the status is yes, this is the character constant, yes, then tax is equal to 0.20 into multiplied by pay. Otherwise tax is equal to 0.4 into the pay. So here S is the character constant wherein which we are checking it against the status. If the status is yes, then the tax is so and so, otherwise the tax is so and so. So in order to get these kinds of requirements in the programming languages or in the C programming, we use the if else statements. Then there is another format of if else that is called as the nested if. Suppose if you have a requirement like if the following condition, following expressions condition is true and the other condition also true and the other condition also true, then you have to execute such so and so statement, otherwise you have to execute other statements. So in order to get such kind of requirement in the programming, fulfill the requirement in the programming, we have the thing like if expression 1, if expression 2, then statement 1, else statement 2, else if expression 3, statement 3. So in this way we can have the nested if, as many as nested ifs as we can have in the nested if statement. And other than this particular nested if, we have a kind of statement wherein which it is a clear-cut way to define these kinds of nested if, and it is called as the switch statement in C language. It is a switch statement in the C language. So this particular nested if can also be taken into consideration by fulfilling a kind of switch statement instead of writing the nested if. Then we have a looping construct called as the while statement. We have while statement, we have do while statement, we have for statement, and starting with the while statement we have while and then expression, then a set of statements. So this can be easily taught with a kind of example. Here digit is equal to 9 and this particular digit we are taking the data type as integer. While the digit value is less than or equal to 9, then we had given some certain set of statements and these are compound statements. Printf %d the digit, and again we are adding that particular digit. Digit is equal to digit plus 1. Here and again we are testing against the expression, testing against the loop, and if it is true again we are printing the printer. We are printing it through the printf statement. Here the basic difference between the for loop and the while loop is nothing but here we are taking the value, the assignment value of digit is equal to 9 ahead before placing the loop. We are taking the digit as digit is equal to 9 and then initializing the variable, control variable digit is equal to 9 and then we are starting the loop here. And suppose if we take the case of the for loop, do while loop, here what it is saying is, here integer digit is equal to 10 and do printf while digit less than or equal to 9. The basic difference between the while loop and the digital while loop, do while loop is that the do while loop executes once even. Suppose if you take the case of the while loop, it may or may not be executing even once. Like if the condition whatever that we are placing it within the expression itself, If it is failing, then it may not be in a position to execute the loop. It comes out. It exits from the loop and it continues with the rest of the statements. Suppose if you take the case of the do while statement, it executes once, then only it will be tested again as the condition. If the condition is true, again it goes to the second iteration. So in this way, this is the basic difference. Suppose if a statement is to be, if the loop is to be executed even for once, then do while should be used, and it is that condition is to be tested, and it is to be going for the second iteration, basing upon the true or the false of the condition. Then comes the for loop. In the for loop, what we are doing is, here basically expr is equal to 1. Here what we are doing is, we are placing the control variable within the loop itself. Like whatever we had placed in the earlier thing, like in the while thing, digit I is equal to 0, and I is equal to 9. There we had placing before the while loop. So here what we will do is, digit is equal to 9, then we will check again, digit less than or equal to 9, then digit is equal to digit plus 1. Here we are putting all the three things within the same braces, and we are executing the loop. So there is no difference between the while loop. You can use while loop also, you can use the for loop also, but you have to know where the control variable should be placed. The control variable in the while loop should be placed ahead of the while loop, and within this particular for loop, we have to place the control variable within the braces itself. So here we are taking the example int I. Here we are we are just declaring the I should be case sensitive, like I have to place it small I, and for I is equal to 0, I less than or equal to 10, I plus plus. So this is how we are doing. Here we are assigning the control variable's value also here within the loop itself, within the first statement itself. Otherwise we have to, in the case of while, we have to place the I is equal to 0 here, we have to write while, and then we have to check the condition here, and we have to place the I plus plus in the later on stage after the execution of the statements. Then there is a statement called as the break statement. So it is a kind of, it can be used within a for, within a while loop, within do while loop, or within a switch statement. The basic purpose of using the break statement is, it is used to terminate a loop or to exit for a switch statement in a convenient way when a condition is met, if an error is met, or an irregular condition is detected. So the basic purpose of writing the break statement, suppose if you are executing some sort of loop using I loop only, for loop. Suppose for I is equal to 0, I less than or equal to some 10, I plus plus. Suppose if you are placing a kind of thing, I is equal to 5, you break out. So suppose if it is meeting a value, you should break out from the loop. So in order to achieve that particular thing, so certain values only we are giving the range, but we have at certain value, and when a certain condition is met in the loop, we have to break out from the loop. For that particular reason, we use the break statement. As well as, suppose if you take the case of a switch statement. In the switch statement also, we write switch expression, then we give the cases, number of cases, and we place the default case at the last. For each case, we place the statements again as that particular case, and we give the break statement there. Because suppose if you don't give the break statement there in the switch, what it will do is, it will check all the cases, and it will, suppose if it is a display statement, it will display all. So there is a need wherein which if at all a case is satisfied, it should execute those particular statements, and then it should break out from that particular switch statement. So there we are using the break statement. Break statement is nothing but we have to place the break, and we have to place the delimiter called as the semicolon. So in order to achieve that particular requirement in the C programming, like breaking out from the terminating out from the loop whenever a condition is met, whenever some sort of error is met, or some irregular conditions are met, we have to use the break statement. And there is another statement called as the continue statement. This is some sort of against to the break statement, and the basic purpose of this particular continue statement is nothing but it will be just bypassing the current pass. Like a control variable is fetching a value, it is tested against the condition. If it is true, it is entering into the loop, and the statements are being executed. Suppose again a certain pass, I is equal to 5, suppose if we want to bypass, and then suppose if I is equal to 6, later it should continue till 10, till the control variable value is 10. Then in that case, we have to bypass one or two values, we have to use the continue statement. So it is used to bypass the remainder of the current pass through a loop. The loop does not terminate when a continuous statement is encountered. It is not at all terminating like the break statement is doing. It is just bypassing that particular pass only, and later on another value is been fetched and the loop is been continued. Rather, the remaining loop statements are skipped and the computation proceeds directly to the next pass through the loop. So in order to achieve these kinds of things, these kinds of requirements in the C programming, we should introduce the continue statement. Then there is a statement called as the goto statement. And this particular goto statement we should not recommend to use, because this is a kind of unconditional branching. We are just moving in some certain sequential fashion, and whenever there is a kind of goto statement is encountered, it was we are altering the normal sequence, we are altering the normal execution of the statements, and we are just jumping to the label and we are executing the statement, and we are not coming back to the other the statements wherever we had left over. So the goto statement is used to alter the normal sequence of the program execution by transferring the control to some other part of the program, and this particular thing can be achieved using the syntax GOTO, this is the keyword, and then LABEL, label, semicolon. And that particular label, whatever, suppose if it is a start or if it is end or whatever the thing, whatever the string that we are placing against the label, that is been given at some point, and then we have to use a semicolon and we have to place the statement or statements to be executed. So this is a kind of unconditional branching. Suppose if that is a requirement in our program, we can use, otherwise we should not use the goto statements in the C programming. Then we come into the actual thing called as the functions. Suppose if you take the C programming, a C program consists of a function or else many functions. The main itself is the main function or the main program, and other than the main function we have several, other than this main function we have several functions within the program. So that particular main functions are called as the user defined functions. So the use of user-defined functions allows a large program to be broken down into a number of smaller self-contained components, each of which has some unique identifiable purpose. So here the modularity in the C programming can be achieved through functions only. So this is a kind of structured approach wherein which, suppose if you have a large problem to be solved, we write a program, but how we write the program is we will modularize the program using the functions, and these particular functions are nothing but those are the small programs in order to achieve certain self-contained tasks. Like avoids, the C program can be modularized through the intelligence use of some functions. It avoids the need of repeated programming of the same instructions. This is the additional advantage that we are getting using the functions. Suppose if you are using the function, the square function, to display some 3 square, 3 into 3. Like suppose if the same square is used for some 5 or some other number. So we can write them as some sort of small program, and then wherever that particular thing is required in our programming, then we can call the function. By passing on the parameter, we can achieve the result whatever we are targeting for. Then there are several types of functions. There are functions with no parameters and no return value. There are functions with parameters and no return value. There are functions with parameters and with a return value. So in C we can use all these 3 functions, all these 3 types of functions. So where lies the difference? The parameter, in the sense, whatever the arguments that we are placing, whatever the arguments that we are passing are called as the parameters. Like suppose, think the case of a function. Within the function, whenever we are declaring the function, at the declaration part, which is called as the prototype of the function, we have to write the return data type. Suppose if the function is not returning any value, we have to place it as a void void. We have to place the keyword void void. Suppose if the function is returning an integer, we have to write int. Suppose if the function is returning some double value d, we have to write it double. And later on, after writing the return data type, we have to place the function name. function name, anything it can be, square, square root, or anything the function name can be. And we have to follow the rules and regulations of the identifier, like it should start with the alphabet or else with an underscore, and it should not start with a number. And then we have to take the limit of the characters also depending upon the compiler and all. So that is the way we have to write the function name, and then we have to place the arguments. In order to place the arguments, the way we have to place the arguments is we have to write the data type of the argument and we have to place the parameter name. So in this way we have to write the arguments, and we can't write like, suppose if there are three parameters of integer data type. So we have to write int a comma int b comma int c within the function name as the parameters. So there are three types of functions as we had learned earlier, and one may be the functions with no parameters. So we are not passing any parameter values to that particular function, but we are trying to execute certain statements by calling them with the name of the function, and then after the execution it returns no value. Like I'll tell you one example. Suppose if we are calling a function to print certain stars, a format of stars, a line of stars, then what we can do is we can call the function star, like I am keeping the name as a star, and write the coding within the bracket that it should display some sort of 25 stars or 26 stars. So after the display is over, it will again, the control will come back to the main program. So in this way we can achieve no parameters and the no return value. And the second type is functions with parameters and no return value. Suppose if you are writing the parameters with parameters, suppose if I want to have the same thing, like within the function I had mentioned 25 stars to be displayed. Suppose if I am passing the stars to be displayed as 5, 6, 7 basing upon the requirement, then what I have to do is the number of stars to be printed I will be sending them as the parameter, and later on those will be printed, and then it will return no value and the program control comes to the main program. Suppose in the same example, suppose if I am giving the if I am passing certain values to be calculated through the parameters, and if the value is calculated and if the value is to be returned to the main program, and that particular value is assigned to the variable, then the third type of function we have to use in which we will be passing the parameters, we will be passing the values through the parameters, and then a return value is expected, and the return data type also should be mentioned in that kind of thing. In the earlier kind, here we no need to mention the return data type, like we can use the void data type itself as the return data type, but in the third case we have to specifically mention the return data type also. So how to declare this particular function? Here I want to say that function declaration is nothing but, in the declaration part we have to mention the return data type, the function name and the arguments, or else we can call them as the parameters. So this is a kind of prototype declaration wherein which we are just writing the return data type, the function name and the data type of the argument that we are passing as the first argument we are passing, and the data type of the second argument that we are passing. So this is the way that we have to declare it at the declaration part, and later on we can call the function with the help of the function name, and after the main program is over we can write the definition of the function. What is the definition of the function? Definition of the function is nothing but the actual statements of the function to solve the specified task. Like here what we are doing is, one way to write the function is nothing but we can write the prototype as well as the definition at the start itself, and the other type to write the function is to declare the prototype in the declaration part. You can call the function using the function name, and you can write the function after the main program is over. User defined function after the main program is over. There obviously you have to put the return data type, you have to write the function name, you have to write the parameters. Afterwards you have to start the function definition with the curly brace, and you have to write the function statements, and again you have to end the function statements. Whenever we are talking about the functions, there is no difference between the main function and the other user defined functions. In this way you have to treat. Like suppose if you are writing a user defined function, within the user defined function also, suppose if there are certain local variables, function local variables are there, those also should be declared. So here the main function itself is a kind of function which is consisting of many other functions. So you can write a main function, or else you can write the main function and the user defined functions also placed at the later stage. And there are two data types which I forgot to say in the basic data types. One is the enumerated data type and the other is the typedef data type. Suppose if you want to use some alias name, alias in the sense, suppose if you are using the float data type or double data type, float data type you are using for the amount is equal to sum is equal to something, and suppose if the sum is to be interpreted as some sort of amount, rupees so and so. So you can take the alias data type, like by placing the typedef, you can achieve the requirement, like the typedef, and then whatever the data type that we are going to write, against that you can use the alias data type, and with that alias name you can call in the rest of the program. These particular things will help in the structures, like typedef struct we will be using. So with that particular structure, name itself we will be calling the things. And then the enumerated data type is nothing but, suppose if you want to assign a value against some days of the week, as Monday is equal to 1, Tuesday is equal to 2, and Wednesday is equal to 3. Likewise, if you want to give certain values to the days of the week or months of the year, for that particular thing we can use the enumerated data type. Like we are putting a range of values there, range of strings there, and we are getting the values from them. We are not trying to interpret that particular thing as a string or a kind of characters, group of characters. We are trying to interpret that particular thing as a value, and that particular value is tested against, or that particular value is to be used in the later on stage. In that particular thing, we will be, in that particular context, we have to use the enumerated data type. So other than these particular functions, we have the arrays also. We will be using arrays. Why we have to use the arrays? Arrays are nothing but, suppose let us take a context example, like if at all a roll number, marks of some 10 students are to be displayed in the same subject. Like, so let us take the computer science first subject is there, CS1 is there. Suppose marks for 10 students are to be displayed. So how you will be displaying the marks of the same course for 10 students? So for the related data items we can use an array. So for the first student we can display, for the second student, third student, fourth student, fifth student, we can display the same subject marks. So in this way, in order to achieve a kind of groupism, like a kind of related data items, we can have the array data type. Suppose if there is a, and for this particular array also, we can use a single dimensional array, a two-dimensional array, or a three-dimensional array, but with the same name. Here what we are going to achieve is nothing but with the same variable name, or else with the same array name, or with the same identifier name, we are fetching several data items. Several items, like A of 1. Suppose if the range is from A of single dimension 10. So here what we are doing, what we are saying is the range is from, in C the range is from 0 to A of 0 to A of 9. So the identifier name is remaining the same, A. And then here we are taking up each dimension, A of 0, the value is something, A of 1, the value is different, the A of 3, the value is something different, till A of 9. So here we are achieving all the data values with the similar name. So or else we are grouping the related data types into a single name called as the array. Or else we can have this double dimension also, two dimensional also. Like suppose if you want to interpret a matrix of 2 by 2 matrix into a program. So you have to take an array of A, 2 of 2, and you can take the values of that particular matrix. So in this way you can have the two-dimensional, even in this way you can have the three-dimensional also. So in order to achieve these kinds of matrix multiplication, matrix addition, or else finding of inverse of matrix, we will be using the arrays. But what is the basic disadvantage with the arrays, usage of the arrays? The basic disadvantage is that it is occupying more space. More space in the sense, suppose if you are declaring an array, a single dimensional array of 10 size, A of 10, and the array is of integers. Integer A of 10 means it is occupying approximately 20 bytes. So 2 into 10 is 20 bytes. Suppose if we are taking the values of only 4 items there, A of 0 to A of 3. So what we are doing is, we are wasting unnecessarily the rest of the things. So the whole allocation is being done basing upon the size of the array, and later on we are not using those particular location. This is nothing but a kind of approach wherein which we are totally misusing or else we are wasting the memory space. Suppose if it is A of 10 and all the items have been filled up, then there is no problem. And what here in the array is the basic thing is that it will give it will allocate the consecutive memory locations. It doesn't do like it will remain some sort of space and again it will continue with the other space. It doesn't do like that. Suppose if the array is of A of 100 size and and it is of integer data type, all the 100 into 200 locations are to be reserved for that particular array consecutively. So that is the basic disadvantage with the array. And then there is a component called as the structure, basic programming construct in C called as the structure. Suppose if you want to have a kind of record kind of thing that is to be maintained in a file. So that particular record, within the record, suppose let us think a case of a student. If at all the student is having, if the student is having the enrollment number, the name of the student, and basically 3 subjects, marks of the 3 subjects, and then total, and then we are calculating the percentage. And this is one single person's record. Likewise, we have several students in the class, like 25 students in the class. And for 25 students, we have to display all these kinds of records. So what we will be doing is, we will be taking a structure as the basic data type, and then we will be placing the student enrollment number, and we will be placing the student name, marks of the 3 subjects, the total and the percentage into a kind of container. That is called as the structure. So we have to give the keyword struct is struct, and then we have to place the structure name, and then we have to individually for each and every element that we want to display in the record, we have to give the return data type, and then it should be ended with a curly brace and then a semicolon. So we have prepared the basic blueprint of the structure, and this particular basic blueprint can be used for declaring the structure variable. Suppose if the student strength is 25, we have to declare 25 students. So these are some of the things that I had covered in this particular session related to the C programming language. In the next sessions, we may be looking into the pointers, file handling, and other things in the due course. With this, I conclude the session. I think that each and every student has understood the concept still, whatever I have told. You please implement them using some sort of programs and execute them. Try to look into the outputs that you are getting and then try to enhance the knowledge in the C programming. With this, I conclude the session. Thank you.